Welcome back to the class on a single phase fully controlled converter with a resistor load. So this is the circuit diagram which is consisting of four SCRs T1, T2, T3, T4. This is leg 1, this is leg 2. Between the leg 1 and leg 2, AC source is connected. Here this point is nothing but A, this point is nothing but B. The input voltage Vs equal to Vm sin omega t. At the output, the resistance is connected. Here we have taken the load as a resistive load. When the load current is passing from top to the bottom, in this manner it is a positive direction of the load current. This is the positive direction of the ultimate load voltage. This is the positive direction of the source current. When the current is passing in this direction, that is nothing but a positive direction of the source current. Now we are going to see the operation of this circuit. The input we have taken as a AC voltage. First we are drawing the two cycles of the input voltage. VAB is nothing but the voltage between the A and B. VBA is nothing but the voltage between B and A. Both are quite opposite, 180 degrees phase shift. So in the input voltage we have represented the VAB as well as the VBA. First we have taken the x-axis, this is the y-axis. This is VAB voltage, pi, 2 pi, 3 pi, 4 pi. Now we are going to represent the VBA voltage with the dotted line. This is the VBA voltage. So why we have taken the VAB and VBA means, suppose if the T1, T2 is conducting, the load voltage becomes a VAB. T3, T4 is conducting, the load voltage becomes a VBA. So we want to draw the output voltage V0 when T1, T2 and T3, T4 is conducting. The output voltage just equal to the input voltage of SCRs. So in the input waveform, we have taken the two voltages. One is VAB, another one is the VBA. During positive cycle of the input voltage, nothing but 0 to pi. A is positive with respect to the B. With that polarity, T1, T2 is forward bias. So we are applying the triggering voltage to the T1, T2 with a delay angle alpha that I have shown here. So one more pulse we are applying to the T1, T2 is at a 2 pi plus alpha. In this case, we have taken the firing angle alpha 45 degrees. So we apply the triggering voltage at this point. When the input voltage VAB is negative means T1, T2 is reverse bias, we should not apply triggering voltage. Again, here in this region VAB is true, again we are applying the triggering voltage to the T1, T2. VBA is positive means T3, T4 is forward bias. That is happened between the pi to 2 pi and 3 pi to 4 pi. In that duration, we are applying to the triggering voltage to the T3 and T4. So at pi plus alpha, we are applying the triggering voltage to the T3 and T4. The same manner, between 3 pi and 4 pi, we are applying the triggering voltage to the T3 and T4. The same delay angle alpha. During positive cycle, the input voltage A is positive and B is negative. With that polarity T1, T2 is forward bias. But we are applying the triggering voltage to the T1, T2 at the same time at this point. So 0 to alpha, no device is conducting circuit, the output voltage becomes a 0. So up to here 0. At alpha, the T1, T2 is on. Once the T1, T2 is on, the load voltage is equal to the source voltage. So from this point you will see how the input voltage changing. You take up the same waveform, same magnitude for the load up to angle pi. Again between pi to pi plus alpha, no device is conducting. Even though T3, T4 is forward bias after pi, we are applying the triggering voltage to the T3, T4 at a pi plus alpha. So T3, T4 will be on at a pi plus alpha. At angle pi, T1, T2 will be turns off because of natural commutation. So now we are going to complete the, at pi plus alpha, VBA voltage, because T3 T4 is on, the load voltage equal to input voltage of T3 T4, that is VBA. So from this point you have to see how the VBA voltage changing up to 2 pi. Next, 2 pi to 2 pi plus alpha, no device connecting circuit, the output voltage becomes 0. Again at 2 pi plus alpha, we apply the triggering voltage to the T1 T2, so it is on. The output voltage is VAB. Next, VBA. Now if you draw the output current waveform, in this case we have taken the load as a resistive load. So I naught equal to V naught by R. The load current waveform is same as the voltage waveform, but the magnitude will be lesser because we have taken the value of resistance in the load is greater than the 1. So this is IAB, this is IBA, this is IAB, again this is IBA. Now we are going to draw the source current waveform, this current waveform. Suppose if the T1, T2 is conducting, that is happened from the alpha to pi. T1, T2 is conducting. Now the current is passing from source T1, load T2, again return to the source in this manner. So the source current equal to the load current, that is positive. So you have to take up the same waveform here, that is positive. Pi to pi plus alpha, no device connected, source not supplying any current, that is 0. Again at this point, from pi plus alpha to 2 pi, T3 T4 is conducting. Now the current is starting from B terminal, T3, load T4, again return to the A terminal of the source in this manner. So the source comes in negative, that is equal to the load current. So the same waveform you have to draw below the x-axis. Again if the T1 T2 is conducting positive, T3 T4 is conducting again negative. Nothing but the T1 T2 is conducting, the source current equal to load current, that is positive. T3 T4 is conducting, source current equal to load current, but it is a negative. So in this manner you have to draw the waveform when the circuit is operating. Now we have to find out the average output voltage. So what is the voltage waveform we are showing here? That is not a pure DC voltage, it is a pulsating DC. So we have to find out the average output voltage. To find the average output voltage, we have to identify what is the area of a curve which is repeating. Alpha to pi, what is the waveform is there, that waveform only be repeating. So this area divided by the base length of the curve over which this curve is repeating. The base length becomes a pi. So the average output voltage equal to 1 by base length integral alpha to pi Vm sin omega t, nothing but this area. If we complete this integration, Vm is constant, take outside, so V naught equal to Vm by pi into 1 plus cos alpha. Now the same circuit operation we are keeping in the table: serial number, angle, conducting device, output voltage. 0 to alpha, nothing but 0 to alpha in this region, no device is conducting, the output voltage 0. Alpha to pi, from this point to this point, T1 T2 is conducting, the output voltage is VAB. Again pi to pi plus alpha, nothing but in this region, again no device is conducting, the output voltage becomes a 0. Again from pi plus alpha to 2 pi, T3 T4 is conducting, the output voltage becomes a VBA. We are going to see how the output voltage will be changing by changing the firing angle alpha. Now take the alpha on x-axis, place average output voltage on the y-axis. We can vary the alpha from 0 to 100 degrees. This is 0, at this point 90, at this point 80. When alpha equal to 0, expression if you take alpha equal to 0 degree, we are getting the 2 Vm by pi at this point. When alpha equal to 90 degrees, we are getting the value Vm by pi, that we are getting at this point. When alpha equal to 180 degrees, in this expression if you take alpha equal to 180 degrees, the output voltage becomes a 0. If you line join all these points, we are getting the variation of output voltage versus the firing angle. As alpha changing from 0 to 100 degrees, the average output voltage is always positive. If we go back and see, this is the input voltage, this is the input current. The angle between the input voltage and input current, that is alpha, this angle. Nothing but by changing the alpha, we can change the angle between the input voltage and input current. That's why we are calling this circuit as a phase control rectifier circuit. We can able to control the phase angle between the input voltage and input current by changing the firing angle. It gives only the first quadrant operation only, because output current is positive and voltage is also the positive, as alpha is changing from 0 to 180. Nothing but always the source has to give the supply power to the load. Thank you.